Hi everyone. This presentation is to cover the watering science behind the watering schedule at the DH Urban Farm. So let's get started. So if you visit the Campus Urban Farm, you'll notice that there is a posted farm watering schedule. And as a docent, you'll want to know a little bit more about the background of how we developed that schedule and what went into it. So the watering schedule posted at the farm is based on an actual formal state methodology. There is something called the Model Water Ordinance, or MWILO, where it actually took the science behind watering and developed a calculation methodology to ensure that you were always applying the correct amount of water to your landscape. So we have utilized that to actually develop calculations and go through it for the different months at the Campus Urban Farm for our different growing areas. It's kind of complicated. You actually need quite a bit of training to actually do this correctly. So no need to worry about that specific details, but we did want to walk you through the major factors that go into those calculations so that you can understand where the numbers come from, understand seasonal changes, as well as use your best judgment to adjust as needed. But essentially the main goal of this presentation, by the end of it, you should just feel really comfortable about reading and understanding the watering schedule and understanding what goes into it. So let's begin. So in order to do the calculations, first of all, the calculations look for how much water does a plant need. So when a plant is growing, essentially needs water in order to replace losses from the evapotranspiration. So that's a combination of just natural evaporation from the sun, as well as the water it needs to survive or breathe. So that results in a certain rate called ETO, or evapotranspiration, which is listed there. And this rate changes, as you probably realize, in terms of, what region are you actually growing in? So are you in the desert? Are you on the coast? Are you somewhere in between? Obviously, seasonal changes in terms of it's much hotter and the evaporation rate will be higher during the summertime versus the winter, right? So obviously, there's a monthly change in terms of how hot it is and how that's going to affect your evapotranspiration rate. On top of that, there's also an inherent drought tolerance to the plant itself, right? So something like a native plant might do really well in certain conditions and not need as much water as, let's say, a corn seedling or something like that. So again, that rate is also affected by how drought tolerant that plant actually is, which is something called a plant factor, which we'll go into. Now, how often you actually need to replace those losses. So on top of actually having monthly losses of, we know this plant needs this much water, it's also influenced by the quality of the soil, because soil will hang on to moisture. There's different abilities of the plant to access that moisture, and that's determined by how deep the roots of the plant are. So obviously, if a plant has very deep roots, it's able to access more of that inherent moisture within the soil, so it doesn't need to be watered as frequently. And we can use this to calculate the needed days between watering that we know that, hey, this plant will actually be fine up and, for X number of days, but then we'll need to replenish the soil moisture. And that's something that we can actually calculate, and that's the irrigation interval, or really how many days between waterings you need to apply for that plant. So to break down the actual evapotranspiration rate, as I mentioned before, plants evaporate water as they breathe. So the evapotranspiration rate represents the regular water loss, or the regular evaporation from the surfaces plus whatever they're losing from just breathing, that absolutely must be replenished for that plant to survive. So there is a reference evapotranspiration rate that the state of California has access to. So this is basically listed in units of inches of water per month needed. So how many inches of water needs to apply per square foot. And that's actually calculated based on science of, how well does high water using turf grow in your specific area and how much water needs to be applied. So the link is there. You don't need to look it up because we already done this for you, but it's something called the CIMMYS database, which is again based on zone, so where you're occupying in terms of where you're growing, as well as the rate itself. So specifically for our area, you can see the map to the right. We're essentially in zone 4, so that's Los Angeles County there. So we're not quite on the coast, we're not quite far inland. So that's the reference evapotranspiration rate that we can use to make our water calculations for our plants. So going into the plant factor, so on top of that, we need to understand, okay, well, we know plants that are high water using need so much water, but what about plants that are maybe a little more drought tolerant? So plants can essentially be divided into 3 categories. One is high, so that's very similar to turf or to edibles like we grow at the farm. Medium is more for things like vines or established fruit trees and shrubs, so kind of medium water using plants, and then really low water using plants, which are very drought tolerant, such as our native plants, succulents, things like that. So they essentially can be broken up into those categories. Um, on top of that, so if you ever encounter a plant that you're not sure of, let's say you're bringing a new plant into the farm, you're not quite sure if it's high, medium, or low, there actually is an official state database called WUCOLS. So you can actually go visit the UKNR website and actually look up species. So if you say, hey, there's this new tree we brought in, we're not really sure if it's high or medium or low, you can actually look up the species and it'll tell you, hey, for your reference or for your zone, it's high, medium, or low, and then you can apply the percentages from there. So generally, if it's a high water using plant, it's about the same as turf, so which is 100% of that water evapotranspiration rate that needs to be replaced. Medium is about 50% of that, so they only needs about half as much water, and low is only about 30% as much water as turf in terms of needing to apply that water to that plant for it to be able to do well. So that's how plant factor is determined for these calculations. So in terms of how the actual water calculation looks, the ETO, again, that's a reference number you can look up. It's inches of water per month. So you look that rate up for your area. In order to get gallons, because inches of water, what does that mean? It's essentially just 0.62 gallons of water for water inch. So to go from inches of water to gallons, you just multiply by 0.62, and that's 0.62 for every square foot. So that's so basically, if you do that calculation, you'll get gallons of water to apply per square foot. So what that looks like in terms of the calculations, so for example, we can look up in the month of July, the ETO rate for edibles or high water using plants in Carson specifically is 5.89 inches of water per square foot. We multiply the 0.62 gallons to get gallons, and then we are able to determine, okay, so for every square foot of area, we need to apply 3.65 gallons to keep high water using edibles alive. So obviously we're going to water more than just 1 square foot. So for example, for our raised beds, that's 16 square feet, right? So in order to calculate, well, how much water needs to go onto this big 16-foot square bed, you can take that 3.65 inches or gallons of water and multiply it by the 16 feet to get 58.4 gallons per month. So that's how much we know we need to apply to this bed to keep that alive. On top of that, that's not very helpful because you're not going to be only watering once a month. You're going to be watering a lot more frequently. So you can divide that by 4 to get the week. So for example, hey, if I divide this by 4, then I know it needs 14.6 gallons per week. Or if I know that I'm going to be watering twice a week, I only need to apply 7 gallons each time, pretty much, to get 14 gallons a week. So that's where the calculations come from. However, if you notice, there is that question of, well, how often should I water, right? So how much should I break up this watering requirement on a weekly basis? So that's determined by the actual frequency of your irrigation days, i.e. how many times do you water per week, which is the calculation that we'll do next. Also, one small caveat, this is specifically for the farm because we're assuming 100% efficiency irrigation if watering by hand. Obviously, it's not 100% efficient if you use something else like sprinklers or drip irrigation, so be very careful about applying these rules of thumb to anywhere else that uses a different kind of irrigation. For the purposes of the farm, we do hand watering, so this is good enough for us. So in order to get those irrigation days, we first need to understand how plants are influenced by the water table in the soil itself. So you need to calculate that by first determining what's your soil quality, which will determine the ability of that soil to retain moisture day after day. And it's also going to be determined by root depth. So if you think about it, a tree with super deep roots is going to have access to way more moisture than a tiny seedling that only has access to that first inch of water. So plants with deeper roots will be able to last a lot longer. And also you can use these values to determine the days between watering in order to replenish water moisture. So how that looks, especially when it comes to, well, how good is my soil in terms of actually hanging on to water, there's actually reference values that are established. So for example, our campus soil isn't that high quality. It's pretty sandy. It's really coarse. It kind of drains water right away. So that reference value is only about 0.9 inches of water for every foot that the the roots go down. So that's not very high. If you get something that's kind of in the middle, so maybe you live somewhere where the soil is a little better, it's a little better at hanging on to water. Reference value for kind of more silty clay loam kind of soil is about 1.9 inches of water per foot that the roots go down. However, for organic soils, like the kind that we have in our raised beds or for our potting soil, really high quality soil hangs on to moisture really well. So a plant can actually access about 2.5 inches of water for every foot of root that it sends down. So as you can see, the quality of the soil will affect the calculations. So essentially what that means is that better soil and soil with more clay will be better at hanging on to water. So that'll influence how often you need to water. Also, the deeper the roots are, the more water it'll be able to access. So for example, a big fruit tree with very deep roots will be able to access a lot more water than seedlings that are in a tray. So that's something to keep in mind when looking at the difference in water calculations. Another thing to look at is the rate of water depletion. So this is how we actually determine how many days between watering we need to go for all the plants. That's determined by the plant's available moisture. So how much moisture it has available to it based on how good the soil is in terms of moisture, as well as how deep the roots are going. And you essentially take that and you divide it by that ongoing evapotranspiration rate of, it's going to be losing this much water every day. And then when you divide the two, it essentially gives you a number of, basically the roots are going to be sucking this much from the soil, and it's going to essentially be dry after this any number of days before it needs to be refilled. So the calculations are very scientific, but basically they're all put into the water guidance chart. However, these are rules of thumb. So conditions can change. It can be a super hot, dry day. Maybe things have been moved around, maybe some water before you. So always make sure that you're checking the plants first. Rather than blindly apply whatever's on the watering chart, definitely make sure to test the first 2 inches of soil with your fingers to make sure it's not still wet. Because you also don't want to drown the plant by giving it too much water and essentially causing root rot. So make sure that there's a balance built into this. So in terms of the summarizing the water calculation of what you see in your chart, first of all, we got the water needs, so the amount of water we needed to apply to that landscape. So again, the evapotranspiration rate, how inherently drought tolerant it is, so the plant factor, how big of an area you're trying to water in that hydrozone, and that'll get you the plant water requirement, or essentially the amount of gallons of water to apply. The other thing we did is to get the irrigation interval or frequency in terms of how often you need to water. It's the type of soil that you have and how much, so as a result, how much moisture that plant is going to have access to, how deep the roots are in terms of the root inches. And also you don't want to flood the plant to give it 100% of its water requirements all the time. So 50% is the general state methodology in terms of the maximum allowable depletion before that plant's going to get really angry at you. And you need to make sure you're replenishing the water needs on that basis. So you get that allowed depletion rate divided by how much it's consuming on a daily basis, and then you will then get the days between irrigation before that amount of water needs to be applied again. So this is the actual watering chart that you will see. This is just a couple line items, but this will hopefully help influence you in terms of understanding how this chart was developed. So for example, if you look at the seedling trays, so let's say you've got some nice starts in this 2 by 2 foot seedling tray. If you look at the watering requirement, let's say for April, you can see that it says, okay, so you need to apply 1 gallon of water to that tray 3 times a week. So each time you go out to water that week, 3 times a week, you need to apply a gallon. And if you notice, the raised beds, for example, has a different value. So this is a 16-foot square area. It's got established plants with deeper roots. So in the same month of April, you're applying 5.5 gallons twice a week. So that's why there's differences in each of these areas, because they've been calculated based on those varying factors. And if you notice the trends as well, so even you can't just say, okay, well, this is the watering schedule we're going to keep forever. You can actually see it changes on a seasonal basis. So for example, if you look at the seedling trays, it's suddenly going from only needing to be watered twice a week because it's more temperate, And then in, let's say, the heart of June, you're suddenly applying a lot more water 3 times a week because that water requirement is going up. And again, if you remember the calculations of what went into it, that's because the season is getting hotter. The available moisture is being sucked up faster. And because these are little tiny seedlings with no root base, they need to be watered more frequently because they don't have access to super deep access to the rest of the water available to them in the soil. So that's where the difference comes in. And if you can see that, that means as a general whole that seedlings are much more water needy that per square foot that compared to the raised beds where you have more established crops and deeper roots. So the reason I mention this is if you ever try to directly plant seedlings into a raised bed, you will need to apply the difference in watering. So this is, even though we try to make it simple for you by assigning these calculations to different areas that we know will be there, the raised bed calculation is based on established crops, not for seedlings or things straight from seed. So make sure that when you're watering, you're adjusting for that, maybe applying more to the seedlings and applying those calculations back and forth. But as you can see, all of the assumptions are listed to the left in terms of what kind of plants we're assuming are in there, as well as the square footage you're applying it to. So make sure you're making adjustments if needed, when looking at the chart. So in terms of final notes, again, we try to make it easy for you by doing all these calculations ahead of time. So essentially, as long as you kind of follow the chart, apply the water evenly across that designated area that's been lifted. So if it says 16 feet, apply it across that 16 feet. If it says 2.5 feet, only 2.5 square feet, actually looking at that square footage, you should be pretty safe. And also in terms of just understanding the variables, again, look out for those changes. So the watering schedule will change based on, the seasonal fluctuations in terms of how hot it is, the built-in thirstiness of the plant, again, the quality of soil. So definitely make sure if you're watering anything that's not planted in the nice potting soil, you're going to have a different amount of water and frequency that you'll need to apply. And again, also very carefully looking at root depth to make sure that shallow plants or new plants are getting more water than super deep plants that have a very deep root structure. So as docents, you now have the full background behind what goes into those calculations. And again, take a close look at those watering schedules, read it with a little more context in mind, and then you'll be one of our watering experts. So thank you. And if you have any questions, make sure you reach out to the Campus Urban Farm.